have two test tubes in front of me, one marked K for the known solution, one marked U for our unknown. So what we are going to do is we are going to fill each test tube up with 2 milliliters of our known solution. So this will be positive for iron, nickel, zinc, and aluminum. And then we're going to put 2 mils of our unknown solution, which will just be unknown B that we're using today for experiment 39, into test tube U. So we're going to start with that first, and then we'll go from there. So I'm going to take the 2 mils of our known positives and put that in the one marked K for known. So here is 2 mils on our pipette, and in it goes into K. And the color, can't really necessarily see it that well, is a bit of a yellow solution at first. And now I'm going to take our unknown, and we'll do 2 mils of our unknown. This is a 1 mil pipette, so we're just going to do 1 mil and then 1 more to make it for 2. Okay. Now that we have our solutions in, the next step that we have to do is we have to add 10 drops of 6 molar NaOH. So we're going to add 10 drops into each test tube, and then we're going to centrifuge these and decant the liquid, and then the liquid we'll save for part D. So we'll set up first, and we're going to put in 10 drops. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have this gelatinous precipitate forming. Now we'll do the same thing. We're going to do 10 drops of our 6 molar NaOH into our U. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you see that precipitate form. So we're going to take these, here they are, you can see it. I'm going to mix it slightly, and we are going to now put these in the centrifuge to spin them down, and then hopefully it'll form a pellet on the bottom. Then we'll come back and we'll add some more NaOH to see if any more precipitate comes out. We have our unknown and our known. We're going to put them in across from each other, and we're going to let them spin. This has been spinning for a while, so we're just going to flip the switch off and let it slow down. We now have our precipitates spun down. So here is our known and our unknown. And what we're going to do is, to our known, we're going to add a little more 6 molar NaOH to see if anything else comes out. If we have anything else that precipitates out, then we're just going to spin it down again. So let's see as we add in, and it looks like nothing, so we're good to go. And let's look at our unknown too. We'll add a little bit here, see if anything comes out of solution. Again, nothing comes out, so we're all set. So what we're going to do now is we are going to try to decant this, and then we're going to put the supernatant aside for part D, and we're going to use a precipitate. So let's do the unknown. I've already labeled another test tube unknown with a D for part D, so we can make sure we're setting it aside. So we're just going to decant these two, making sure that we only get the liquid and not that solid. So we're going to save our part D, unknown D, and we'll put that back there to save. Now we're going to do this. So we're going to decant our known, So we're going to take this liquid and we are going to save that. And here's our known. We're going to use this one now. So what we have to do for our next step, because now we'll be on part B, we are going to add some concentrated HNO3, so nitric acid, to dissolve the precipitate. So we have our concentrated HNO3 here. We're going to add as few drops as possible in. Here we go. I'm going to take this and just mix, and we're going to see if it dissolves. So far it looks like it is. So we're going to add a few drops over to our unknown and see if we can get that to dissolve as well. So here is our unknown. We'll add a few drops in. And we're almost fully dissolved. Okay, so our unknown is dissolved. We're ready to go. And our known just has a little bit left, which I think if we keep moving should dissolve shortly. So the next step, once we have dissolved our precipitate, is that we are going to add 5 drops of our NH4Cl, our ammonium chloride. And then we're going to add in some NH3. So we're going to add a base. We're going to bring it back to being basic. So we're basically all dissolved. I'll move our concentrated HNO3 out of the way. So now we're going to add in our 5 drops of NH4Cl, so 4 molar NH4Cl. 5 drops to our known and unknown. Here we go. 1, 2, 3, 4, 5. Same with our unknown now. 1, 2, 3, 4, 5. We have a nice yellow color going. And the step we need to do next now is we need to add our concentrated NH3. So, and then we're going to hopefully see a precipitate form, and then we are going to take that and centrifuge it like we have in the past. So, we have our concentrated NH3 right here. We want to be careful with this. And we're just going to add enough NH3 to make sure that we are basic, okay? And in order to be basic, we are going to use our red pH paper. And if our red litmus paper turns blue, we are basic. So we're going to take out a few pieces. We'll get them ready. I'll put one up here for our known, one over here for our unknown. I have some glass stirring rods ready. Here again is our NH3. And we're probably going to need to add a similar number of drops. So let's start off. Six drops in each. And now what we're going to do is we are going to see if we're basic. Mix a little. As you can see, we had a little bit of a precipitate form when we were doing that. Here it goes. Oh, you have that nice gelatinous precipitate here. We had it and then it went away. I think we need a little more. So let's just check our pH. Okay, we turned blue and we are basic. Now we need to check our pH on this end. We are still definitely red, so we need to add more. So we're going to add more NH3 to our other side. We add about 6 more drops. And there we go. We formed a little bit of a solid and then it went away. Let's try again, see what we are. We are still pretty acidic, so time to add some more in. So we added 6 more in. There we go. We have a nice solid now. And the solid seems to be staying, so I think we are basic. So we're going to test just to make sure. And there we go. We turned blue. And just to be on the safe side, we're going to add 2 more drops over in here. Okay. And there we are. So we're going to take these now to the centrifuge and we're going to spin down the precipitate so we can have our supernatant to save to go on to part C. Here is what we spun out for part B. This is just after leaving the centrifuge. We are now going to decant into our tubes for C and then test our precipitate. So this is our unknown. So we're going to pour that out. And we're going to save the liquid for part C. And we're going to do the same with our known. We're going to pour this out. And we're going to save the liquid for part C. And a little more gelatinous. Okay, so what we have to do to our known and unknown now is that we have to dissolve our precipitate in 6 molar HCl. So we're going to work with our known and unknown. Here's our known. Just going to add 10 drops at first. Now we're going to mix to see if we can get that to dissolve. Okay, good. All dissolved. Now we're going to do the same with our unknown. Just going to add 10 drops to start with. And we'll mix. Okay, we are dissolved. Now that we are dissolved, what we have to do is we're going to add 5 drops of our NH4 SCN. And if we see a blood red or brick red color, it means there is iron present in the sample. Okay, we don't even have to go to 5 drops. There's that brick red. So there's iron present in the known. And there is iron present in our unknown. So we have that brick red color. So we are positive for iron in both our known and unknown. So now we can go on to part C. So in part C, we saved our supernatant, and we are going to test that. So in part C, we're testing for nickel. So what we're going to do is we have our dimethylglucosamine, and we're going to add some drops in to see if we see a pink to a brick red color. Any presence of red like that means we have a positive for nickel. So our unknown is positive for nickel, and our known, again, positive for nickel. So both of these are positive for nickel. Our unknown and known are positive for nickel. So now we just have to follow up with our original supernatant that we put aside for D, and we are going to test that next. So we're going to look at part D. So we have our solutions that we had from before, our known and our unknown. And what we're going to do is we have to acidify them first. So the first thing we're going to do is take out some blue pH paper. And when blue pH litmus paper turns red, we know that it is acidic. So we are going to add a few drops of 6 molar HNO3 to make sure that they're acidic. So we're going to add just 3 drops each one, and then we'll test them first. Then we'll test them and go from there. So we'll 1, 2, 3, and then 1, 2, 3. Again, we're in just part D. So now we're going to take our supernatant, and we're going to test to see if this pH paper turns red. We're still blue, so we need to add more in. So 1, 2, 3, 4, 5, 6. We added 6 more. Let's see if that works. Give it a little stir. Still blue. Time to add in some more. Still blue. And we should be getting there now, but we're still blue. So we're going to add in a little bit more. And it's funny is we're going to turn this acidic and then bring it to being basic again. So here we go. New piece of paper to test. Okay, and we are there. So we are acidic now, which is good. So we're going to put that over there. Now we got to do the same to our other one. So we're just going to add roughly the same amount, and we'll test it. Still basic, so we're going to add a little bit more. Give it a little test, and there we go, we're acidic. So both of them are now acidic. So now that we're acidic, we're going to make them basic. So in this case, to go to basic, we're going to take out some red pH paper, or red litmus paper, to test. We'll put a piece on for each one. And remember, we want our red to turn blue, and blue means that we would be basic. And instead of 6 molar HNO3, we are going to use 6 molar NH3, or ammonia. So we're going to add a few drops to make it basic, and then from there we will heat it in a water bath for a little bit, and then we'll centrifuge it. So we're going to add a few. And I'm going to add a few to this one as well, same amount. Okay, give it a stir and let's see if we turn blue. We're good. Same here. Okay, so now we have turned them acidic, now we've turned them basic, and now we're going to add them to a water bath. What I wanted to point out, and I wasn't sure if it was visible from there, is this is still part D. Before we put it in the water bath, if you can see, there's this gelatinous precipitate that did come out in both the unknown and known. So what we're going to do is we're going to heat this for a little while, and then we're going to spin to get that precipitate down at the bottom. We just took these out of the centrifuge. We have our unknown and our known, and we spun them down, and you can see we have a precipitate in each one. And now this is from what was resulting in part C. So now we're going to test for aluminum and zinc. So what we have to do is we have to separate out the supernatant and save that for our zinc test, and then we're going to test the precipitate to see if there's any aluminum in there. So I'm going to put these here for now. We have our known and our unknown. We are going to mark 2 new test tubes. We're going to call one KE and UE. So we have our unknown for part E and our known for part E. And remember, part E is going to be that zinc test. So we'll take our known, decant that, and we're going to save the precipitate on the side. Save that for later. We're going to do the same with our unknown. Here we go. Put it here. Save this for later. Now what we have to do to our actual precipitates is we have to dissolve these and digest them, and then we're going to test them with our aluminum reagent. So what we have to do is we're going to add 6 molar HNO3 to dissolve them, and then we're going to see and add our aluminum reagent in, and if we see a red precipitate that comes out, we're positive for aluminum. So we need our 6 molar HNO3, and that's what we're going to start with first. So here we have 6 molar HNO3, and we are going to dissolve each precipitate. Don't need too many additions. We just want to dissolve it. Okay, so we are dissolved, and we just want to double check and make sure that we are acidic. So in this case, if we are acidic, we're going to take some blue pH paper, and that means that we will turn red. So here's 2 pieces of blue, and we're just going to see if we are acidic. So let me grab our stirring rods. And here's our known. Looks like we are acidic on our known. I'll put this away, and we'll test our unknown. We are acidic there too. Sorry. You can see that red dot. Okay, so we're good to go. So now we just need to get our aluminum reagent. And hopefully we'll see a red precipitate, meaning we are positive for aluminum. And it looks like in our unknown it is no. It's definitely a negative. And I'm just going to take this one out, our known. Let me add just a little bit more. And we're going to see what happens here. Hopefully we will see that red color. Okay, I just didn't add enough. So we have a little bit of a red precipitate starting right at the top. So we're positive for aluminum in the known and negative in the unknown. So no precipitate forming here, and on this one we have a precipitate right up at the top. Oops, sorry. So see how you can see that precipitate just hanging out there? All in those little pieces. This is positive for aluminum. This one on the other hand, no precipitate, negative for aluminum. So no aluminum in the unknown, positive for aluminum in the known. So now what we can do, I'll move these out of the way. We can take our last part, which is going to be looking at the zinc, so part E. Now, in order to do part E, what we have to do is we are going to take that supernatant and we have to add some drops of 6 molar HCl, and then we're going to add 3 drops of our K4FeCN6, and then if we see a light green precipitate, we have some zinc in our sample. So again, we're going to add some 6 molar HCl to start to make sure that we are acidic. And then we'll add our other stuff. So we're just going to add 5 drops to start. Remember, this is the one where we went to acidic, then basic, then acidic again. So we're just going to mix these by hand. Now we're going to take our glass stirring rods. Again, if we're acidic, we're going to turn that blue paper red. So here's a piece of blue paper. Dip in. Still blue, so we need a little more. And if we try the next one, our unknown. Okay, so our unknown, we're red, we're all set, but our known, we have to add a little more HCl to it. Let's try this. And hopefully now we'll be red. Okay, we're red. So we're good in that end, that we are acidic. Now what we have to do is add our reagent to see if they react. And the reagent that we are going to add is this one here, sorry, 0.2 K4FeCN6. So we have our known and our unknown. I'll try to hold them like this so you can see. Move my glove. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if we see a greenish blue precipitate, any greenish blue forming versus just that yellow, we know we're positive for zinc. And here in our known, so our unknown, we're just this yellow color, same as the solution. But in our known solution, the one that should test positive, you can start to see that we're starting a little bit of blue, a little bit of green in there. Not so much in this one. I'll hold them side by side. You can kind of see yellow, a little more green. Let me try to change the white balance so it looks a little bit better. Let's try that again. So we have a yellow and more green. I think I just need to add just a little bit more so you can see it. You should be all set. There we go. So now you can definitely see that green coming through. Okay. And no green, and right up top we have that limeish green blue hue. So just to review, for zinc, our known is positive, our unknown negative. And then